Okay. Hello, everyone. My name is Evan. I am the lead programmer on Team 930.
And I'm Efram, and I'm just normal programmer on Team 930.
So we're going to talk to you a little bit today about Maple Sim, what it is, what it's going to do for you as a team, that sort of thing. So just to get started, we have a table of contents. So we're going to first talk about what is Maple Sim. I'm sure some of you might have heard of it already, but we're just going to give a general overview. We're going to mention Advantage Scope. This one's definitely a bit more common, and it's going to be the framework for what Maple Sim works off of. We're going to talk about why you should use Maple Sim, all the benefits it has, all that sort of stuff. We're going to talk a little bit about projectile simulation because that's another really important part of it. Then we're going to talk about some actual code changes that you're going to need to make if you want to implement it and what that's going to look like. And then we just have some Outlook links and recap to finish this off. So, to start,
First, what is MapleSim? MapleSim is a physics/simulation engine that simulates 2D forces and collisions with field elements and game pieces for FRC purposes. So, as this video shows, you can use MapleSim to simulate game pieces and the walls that so then the walls so it like collides with the walls. So yeah, brief introduction. MapleSim functions through advantage scope simulation, and it's made by Iron Maple from Team 5516 from Tianjin, Guangdong, China.
yeah, so Maple Sim's just a pretty much full physics sim for everything you'll need FRC based. So what is Advantage Scope? Some of you may be asking. So Advantage Scope is a robot diagnostics, logging, and simulation tool. Our team uses it quite a bit for getting information on our robot before we go on the field, where we can log stuff that we're getting from our code and simulation, and we can get things out of the field, or while we're on the field, through just like data recording and stuff like that, getting where our robot is positioned, like mechanism wise. We can get our angles for our arms and just anything that's moving, pretty much. So it can be used for visualizing robot on a field, which is the basis of where MapleSim comes into play. It just gives us a 2D position, but that's all MapleSim needs to actually simulate 3D objects. An advantage scope is necessary. Yeah, it's necessary for MapleSim to function. So now that you know what it is and what you sort of need to know for the basics, talk to you why you'll use it. So knowing how your robot's going to interact with an environment is vital for preparing for the robot's success on the competition field. So if your driver, for instance, hasn't actually tested the robot themselves yet for any reason, like it could not be fully built yet or something just, yeah, if you just need a quick test, having 3D simulation of game pieces can be really useful for being able to know how your robot's going to perform in a more realistic setting than just like passing through walls or not interacting with game pieces usually would. It'll also help for seeing how your robot's actually going to score a game piece, because even if your robot looks like it might, the Maple Sim simulation will actually show you whether or not that game piece is going to land on something and if it's going to stick on there. Like, for example, the coral. Sometimes if you see a robot score something in simulation, you're going to be like, oh, yeah, that's going to work. And then you'll go out onto the field and it's going to try and score and it's going to bounce right off. Like you scored too hard. But if you actually have the simulation, you can see how the game piece is going to interact real time. So also simulation before practicing in simulation before the robot is fully mechanically completed gives more flexibility in design. So when you actually have the robot in MapleSim, you can have your drivers test with the robot and see how they think it'll feel. So they'll be able to test it and see the robot interact with game pieces. And if they like something that the robot's doing, like how it's scoring algae very quickly and effectively, and it's not like bouncing out or anything like that, then they can say, ooh, that's a really good design choice that we've made, and we can keep it like that for the robot. But for instance, if something's not working, they can always have time to adjust it before the robot becomes mechanically complete and it becomes a whole other issue to rework your whole room. So yeah.
We're going to talk about projectile simulation. MapleSim allows for complete simulation of projectile physics, like this, how you can throw a note across the field, and then you can throw it into the amp too. It's especially useful for shooter games when precise physics engines can be useful for predicting scoring algorithms.
Yeah, so just in general for scoring game pieces that have any sort of physics, so just any game piece ever, projectile simulation is pretty much just necessary to see whether or not you're going to confirm a score.
You can use MapleSim documentation to start using MapleSim. It also uses Advantage Help to visualize the robot and game pieces. So we'll first look through our code. So if I can, yeah. So if I can go over here. Um, so
Can you zoom in?
hmm,
Zoom in on the code. Oh, it's really tiny.
we can go look at everything. First go this one. So this configures drive simulation to the MapleSim configuration. And then this adds the train simulation off the drive simulation that we created before. This for sim, and then this one's just initializing for the real. And then this is like how you score Coral. We go in here. We have one for L1, which this is all the configuration you can do to make sure you can configure it right, like L1, and then we got L2, L3, and then L4. So then you can or you can spawn a coral onto the reef. If we go back here, this is like just MapleSim spawning pieces button bindings. This is like another controller for MapleSim buttons. And then this can spawn a coral too. If you press this, and then this one, it drops a coral from like the coral station. This resets simulation and game pieces, and this makes sure that it's updated. And then this logs everything for intake or MapleSim, like the pose or the coral algae, and then also game pieces, which checks how many game pieces that your intake has. This is a big one where you can customize your intake, like what things you want, like coral, your drivetrain, width of your intake, like meters, um, and then the back if you're intaking from back, and then this is make sure it sets run, and then this also make sure there's a game piece inside the intake. Then this drops the coral from coral station. We go to drive. And then this is robot configuration where you can configure like your motors, how many motors you have, your bumper size, your mass, all those stuff, and then this it, this simulates time passing, so then the motors will be able to move faster than simulation. And I just had this from the documentation. So, now I can go over to the documentation that we have. It's the MapleSim documentation, which you can get started with templates, like all of these, like the swerve code, all this. We use this one, the Vantage Kit Talon Swerve template, because it fits our motors. And then there's like guides for like everything, like intake, where you can like tells you how to configure intake. Rescape is all about like configuring how you can use coral and algae simulation. Projectiles is simulate projectiles, all what there is. And you can also sim robots on the field too. That's what that is. All in all, this is a good resource for all things MapleSim. And I think that's it.
Okay, so now we're going to talk a little bit about some additional features that MapleSim has that could be of use to you guys. So one of the really cool things is AI robots, which you can summon to interact with field elements along with your robot. So basically, what this means is you can take the MapleSim code that they use for robots and you can implement that into the MapleSim framework itself, and then you can have, as you see down here, little mini robots driving around. Not mini, they're the same size as regular, but they're other robots just driving around with yours, and you can see how they actually interact with your robot on the field, and you can see them actually performing like they would in an actual FRC match, as they're intaking things from stations, they're scoring things in. This is Crescendo, obviously, but it's an old game, but they're intaking and scoring like they would in an actual match. There is framework for um, Reefscape currently, but we just did not implement that in time. So this is just what they have for just viewing wise. But you can see them interacting with robots and scoring stuff, and it's just generally pretty neat to be able to have that there. So you can, again, if your drivers want to have a little bit of additional practice and just see how the robot would feel just generally before it's fully done, in case I want to make changes, this is another great way to do that. I mean, if you have all the CAD ready and just want to throw it in here, it's a really good option to be able to simulate stuff like that. Additionally, besides having just this like default code, they can also be configured to follow a path planner path. So path planner, for those of you who don't know, is just a tool that we use and that many other teams use that just lets you basically just draws auto paths and like implements commands through that as well. And you can sync that up with this and have robots just running like basically long auto paths if you want to see them do something specific. And they can also score stuff like that as well. So that's just a really neat thing that MapleSim can do that lets you get more realism on the field while being completely simulated. So outlook-wise, MapleSim will be usable next season, but you will need to wait a little bit for Maple to actually implement the game pieces, because that's going to take a minute, like for them to get physics working once the game's released. Like you're not going to have a day one, like it's an FRC team. They've got their own things to work on, but they will have it available. And they've also been very vocal about keeping MapleSim up to date with the changes in seasons and stuff like that. So for the future, this seems like a very sustainable um, framework, and it looks like it's going to be a really great option for simulating things more realistically moving forward. All right, just to recap, what is MapleSim? MapleSim is a physics-based software that lets you simulate game pieces and wall interactions. AdvantageScope is just a simulation framework that MapleSim is built around. Why should you use MapleSim? Well, because it gives you a more realistic expectation of what you can expect on the competition field. We talked about projectile simulation and how that works. We discussed how we would use it, so we gave you a little run through of the code. Gave you some additional features, like the AI robots and just some Outlook stuff. But also for, I think we have a, no,
Wait,
what happened to our link slide?
Oh no. Uh-oh.
Oh no.
I'll fix it.
Okay.
You guys will have access to this presentation. Make sure the links are in.
Okay. Cool then. So we last thing I wanted to say was that a lot of the framework that we had put in our code is reliant on our robot specifically because of the types of motors we're using, the types of the software that we're using, that sort of thing. So if there's any like differences there, you can always check the MapleSim documentation. It's pretty reliable and like very easy to go through. Otherwise, though, we do have an example project for you guys. It's in the links.
Yeah. It's
Okay.
in the links.
So whenever the link slide, whenever you guys can get the link slide, we'll have it available for you guys, but it'll be there. We'll have an example project and just the MapleSim documentation and other stuff. That'll be useful. Questions? Yes.
Is it pretty extensible? If you wanted to make a tweak to how the game piece gets in the simulation, could you be like, the ball is more bouncy?
No, not really.
It's like,
Yeah, it's just closed.
so you need to wait for them to be like, here's the ball.
Yeah.
Do you know how long it took them this year?
I don't think they recorded it, but
We started this.
yeah.
That's fine.
Definitely Java. Did the documentation say Python?
I don't recall, but just check the.
Yeah, the documentation should know.
It has to. It runs on top of the flash. Too many other questions. You guys should probably demo it.
Okay.
Do you have?
Yeah. That.
So we are very much learning this right now. So we are just getting bits and pieces working. He'll show you that. The one video, which I was kind of hoping you'd emphasize it a little bit more, we are actually trying to push the code a little bit over the summer, and we got it to basically turn the field into a ball pit. And we were running the robot through the ball. This is a show of hands. Who all uses Advantage Scope to play the program? So we like to say we're one of the few teams in Wisconsin that we can simulate pretty much 100%. We saw this over the summer and we thought we kind of get a little bit realistic practice and maybe some testing and tweaking of our robot for next year, and that's why we wanted to kind of bring this up.
I'm more on the CAD side. Just a general question. What camp format do you usually bring in?
So yeah, so Advantage Scope requires a specific format. I don't remember it off the top of my head, but Advantage Scope does tell you which format. The other thing to note with using the real robot, which you will see our actual robot in this code, it should be, right?
Yeah,
This is the one
I think so.
Yeah.
You actually, it's not as easy just to import it. You actually have to physically move every component into the relative to your drive case. So it's not trivial. It's a little bit of a work to get it working, but once you get it working, everything
Yeah, I'm trying. Yeah. Alright. Now we're gonna press volume.
You can see advanced scope is on the left. The actual WPI simulations on the right because they kind of work hand in hand. There's our actual robot from last year, and he's able to go through, show him that you can move the components. Can you do one of the placements?
No, I don't have my controller.
Okay, you need one. But yeah, and so we don't know. Yeah, you can't interact with the cages. We haven't figured that out yet, but he's figured out how to prevent us from going through the walls. Because if you guys have ever used advanced scope, you can go through everything. And there's no physics or collision whatsoever. He can hit walls. And then I know he's gotten it to summon pieces in and stuff too.
Yeah, I just don't have it.
More pieces cause more chaos. Hit more stuff.
Yeah,
I
Yeah.
can't.
Oh.
I don't have the
it's really
controller.
cool. We're still learning it. If you guys learn anything, we are totally open to any information you guys have, so we can kind of combine it all together. We have our own online documentation too that we can give you guys access to, where we document everything we do. That's us in a nutshell. Jeff, if you have any questions, talk to us while you guys are here, and glad to help.
If there's no further questions, I think we're at our time. All right, thank you all.